Hello, everyone. Good afternoon. This is Girish Gajwani. Hi, thank you for joining in. Um, I've spent the last 2 decades in fintech, of which the last 10 years I've been involved in like leading digital transformation programs across some of the more complex areas in financial services, from wholesale lending to securitized products. I've seen platforms go from legacy monolith systems to agile AI-driven platforms that can process data in real time. What I've learned over this period is that success for these platforms isn't just about adopting new technology. It's about it's about understanding the business problem, what's the desired business outcome, and architecting the right platforms to deliver the impact for the users. So today I'm going to go through my journey with some real world scenarios and strategies and results for the digital transformation of financial platforms. So let's get started. So let's start with the question why. Why are we moving from monoliths to microservices architecture? The evolution of this process. So basically, like traditional platforms were built on monolith back in the day. All the functionality was clubbed together on-premise architect infrastructure. There was limited scalability. Like any small changes coming in had to be tested thoroughly across the entire application and had to be redeployed. So there was a lot of tight coupling between functionalities. Those were some major issues where even smaller changes would take weeks or even months to deploy to go live. So that was a problem statement. So as we are moving to solve this problem, we are moving to the microservices based architecture, where each and every service is independent, isolated component, right, which can be deployed separately, can be scaled individually, and can be updated without any impact to the rest of the system. So this means there's faster innovation cycles, lower risk, and a platform that's ready to evolve with the business. So it's all business driven separation. Then moving on to microservices architecture, the foundation for modern lending. So I'm going to give examples based on fintech, but this can be applied across industry. It's not this framework is not specific to financial services. This can be applied across different industries as well. So as we go into the architecture, the API gateway, starting with the API gateway, which acts as a single point of entry. It's like a front controller which receives all the requests that are coming in and then streamlining the access to all the services. And then the service registry ensures that the dynamic discovery and routing of these requests is done correctly. So components can find each other. And then to add the ability for real-time messaging or asynchronous messaging, we have event-based data flow. So that's critical for loan processing and other decision-making services. While wrapping on all around it, we definitely need a security framework, which kind of ensures or enforces any kind of entitlements or authorization or authentication that is required for compliance and trust. Because services are independent and loosely coupled, we can deploy updates much faster. So moving on to the next slide. So I want to quickly go through a case study of syndicate loans platforms that I've been involved in different organizations in the last decade to kind of put some baseline on as we are moving forward. So the case study is from syndicate loans, which one of the complex parts of lending, working on monolith systems, struggle with high transaction complexity. So every deal that was involved in syndicate loans, where you have multiple lenders and a single borrower, required different stakeholders. Like multiple stakeholders are involved, numerous documents are involved, and there are intricate allocations involved there. To architect such a solution, you have to create like there are many operational bottlenecks, or we have to add new features. Was becoming very difficult with monolith systems. So that's where there was a high demand for moving to a microservices based domain driven architecture, so that we have that level of separation between every functionality. So to take an example, like origination as a functionality, or settlement, or reporting, all of these need their separate swim lanes or their separate components. So that's how we kind of define the microservices architecture here. With every business functionality will have its own component or service to manage without disrupting the others. So we've seen like significant results here with almost 70% reduction in deployment times, faster to market, and uptime also going above 90%. So those were some significant advantages here. Then moving on to workflow orchestration. So this is a big piece that has come in with uh, like orchestration of workflows using AI. And even from a digital transformation standpoint, there are many manual steps which are involved, which had to be automated. So again, going into loan settlement scenario where there were different set of stakeholders or users had to make approvals, KYC checks at different stages in this whole life cycle or workflow uh, process. And it used to take days, like reaching out, sending emails, sending chats to different users to approve or to move the workflow forward. And also with manual reconciliation, it used to take days to reconcile all the data from these huge documents. So as we've talked about these different steps that required manual updates and document verification, so there was a clear business outcome required to move to the microservices message queue based architecture. So this allowed us to synchronize the transactions between not just internal stakeholders, but external systems as well in real time with messaging capabilities, real time messaging using MQ, and internal messaging using Kafka. So that kind of really helped move things forward. And the results have been dramatic, as we've seen in different organizations. The cycles which used to take weeks have just come down to hours, like a day, or within hours now the whole process is complete. So that's a drastic improvement. And then moving on to, yeah, so to dive deep into the AI powered document intelligence, I think this is a use case which is used heavily in the financial space, because there are huge documents that are received especially in the lending space, where we have credit agreements, funding memos, and term sheets sent by servicers, clients. So they're like almost 100 pages long, right? Highly complex documents where we have to the user has to go pull out some numbers or economics from these documents, extract that, and then plug it into to reconcile those numbers. So there's a lot of risk for human errors. So we tackled this mainly by using AI-powered document intelligence using NLP models to specifically for financial documents. So this not just helps us in summarizing these documents, but also extracting the economics and reconciling it while trade matching or allocation settlement. So there again been a huge impact with automation for using this process, almost more than 80% in processing time and 40% drop in operational costs. So these are some of the major advantages of uh, document intelligence and summarization. Moving on to the hybrid cloud architecture. So typically with financial institutions, they're going with hybrid cloud approach because again, it's on-premise. There are certain services which are going to be sitting on-prem, and then there are certain services which are uh, sorry, I was just checking the chat if everyone can hear. Okay, so yeah, certain services which are going to be sitting on-prem, and then there are certain services which will be in the public cloud. So to to manage the data, like if there is a secret or private information, we cannot take it to the public cloud. So for those services or secret information, that has to be staying on-prem, and some of which has to be obfuscated as well. Also, with the linkage from on-prem to public cloud, different public cloud providers is can be done for taking an example using AWS Direct Connect, which provides us a secure, low latency link to the corporate data centers. And then, in terms of structuring the microservices, there are different options that people have, the companies have moved on with, like ECS based microservices setup, where in EC2 launch time, that has to be managed by the team, but transitioning to more EKS or Kubernetes based is more self-managed kind of infrastructure with auto scaling. So that has really helped with the microservices architecture. Also, in terms of the data layer, so in the lending space, we have a lot of documents that are received which are completely unstructured. For example, like loan documents will come with a completely different column set. So those have to be staged into a document DB, like an unstructured Mongo database, or like another document options, like unstructured document DB options can be used there to store that data as documents. And there are different design patterns. For example, like CQRS could be used to write commands and to read queries for scalability. So that really helps with the distributed system architecture. And then moving on to APIs for client interaction. So with security, one of the top priorities, we need to make sure all the REST API request response based is uh, going over a secured socket layer, like through HTTPS. And for push-based communication, we can also use something like WebSockets for status or settlement events to push that back to the UI through WebSockets. And then streaming for real-time asynchronous communication between these services, MSK has been a good option, which has been used across, specifically for AWS. And then on-prem is Confluent, Kafka, and other solutions. We'd also tried RabbitMQ, but I think we went with Kafka as a more stable solution. And then in terms of storage, S3 buckets for firstly landing the file and then taking that, processing it, and persisting it into the database. Also, from a monitoring standpoint, AWS provides like CloudWatch and other observability tools where we can go with App Dynamics or Dynatrace to look at the pure path. So this is like a high-level generic architecture that I wanted to go through from a digital transformation standpoint. And now moving on to continuous delivery, like a CI/CD pipeline architecture. So this has evolved a lot over the last few years. Um, Now, engineer to deliver speed, at the same time having quality and compliance. So teams have started leveraging GitLab Duo AI-assisted code reviews. So that has helped the developers as well as the reviewers to go through the pull request and improve productivity there. Also automating the build pipelines, either we are doing it through Jenkins or TeamCity or directly from GitLab. So those are some of the different options that can be used. But at the same time, it has to go through the validation stages, like for security scans with Sonar, Prisma scans, and vulnerability checks are very important to kind of go through the build pipelines. And then finally, when it comes to deployment, whether we are going with AWS or on-prem Kubernetes cluster based, there are different ways to automate that using Helm for Kubernetes, and then with AWS service catalog products to deploy that and have that end-to-end build and deploy pipeline to automate the whole process, which has improved a lot over the last few years. And then for database deployments, also now there are a variety of options available, like Liquibase, which I've been using a lot in the last few years for database releases to get a clear schema checks of what is the delta, what's going in. It has to be, again, a human has to be in loop to verify that, but it really has helped in the automation process. Then moving on to, so this is an important aspect that I wanted to highlight in terms of stakeholder engagement and aligning the MVP development strategy. So when we are going into large scale programs with like in financial or any other area as well. It's very important to kind of define what is the minimum viable product, because it's not just technology that we're trying to deliver. It's what we kind of scope it out and have a minimum viable product delivery or scope that is agreed on with all the stakeholders is very important. And it should be more iterative delivery model as compared to going for a big bang in 2 years, right? So identifying the core functionalities that would make immediate business impact, getting that agreed on with the stakeholders, and going with that deliverable. So this is extremely important with keeping the product owners in loop, business side also in loop all the time. And then having show and tell sessions or demos periodically has really helped in this process, so that everyone is on the same page on what's the business outcome, what's the product that is going to be delivered, how it's going to be used. And there is no mismanagement in terms of expectations. So everyone is on the same page. So that was mainly for the MVP delivery. Then moving on to domain-driven design. So this is another important aspect. Is a foundation of robust platforms, not just financial, across the services platforms. So breaking it down into different domain-driven services, like the design is breaking it down into services uh, which are completely isolated and independent. They have a bounded context, a clear business defined by the business context, where you have well-defined responsibilities, and there are no unnecessary dependencies there. So, if there are any shared framework that can be used across services. So it's mainly defining the domain level entities, and those dotted line boundaries is very important for structuring the microservices architecture, right? And this really helps in scaling. So let's say if we have some issue, for example, with a trade service, so no other service is going to be impacted, only that component, only that business user is going to be focusing on that. And it can be deployed in isolation by touching any of the other components. So yeah, that has really helped in recovery from failures. Okay, so moving on to data lineage and some of the regulatory compliance here. So this is data lineage and this is mission critical, right? That's why we build comprehensive data lineage across the system. We need to understand right from the source where we receive the data attribute to the destination where it's disposed of or it goes downstream. Right? We need to have a clear lineage, which is the authoritative data source for that particular attribute, and where having a pure path on that. So having complete transparency, for example, any loan attribute, you need to have a complete loan life cycle defined, where it's in the transaction. So on the top, we've kind of embedded compliance mechanisms to generate audit trails, and yeah, this really helps in kind of defining the data lineage. Moving on to the next one for monitoring and observability. So I think monitoring and observability also is a very important component. Like as we were talking about data lineage, uh, having a clear picture of the solution, like of the platform, uh, if we come across any issues as we're going live, for example, like a database table lock or index related issue. So we can isolate that, or that can be proactively detected and resolved without the user facing something on the UI and coming back to support teams or to different stakeholders to address that. Right? So monitoring and observability. There are different tools that have come in with now AI coming in with, which is also helping with automating the root cause analysis and self-healing actions and recovering from failures. Also with Netflix Hystrix is also helped there. So yeah, that's mainly for monitoring and observability. And then Finally, I would like to go through the overall transformation journey in terms of the methodologies that we've used over the years, like with Agile, were critical, and with iterative deliveries, as I talked about, and having close collaboration with stakeholders, keeping all the different stakeholders involved in all different points of time, and having a clear vision right from the outset is very critical. Uh, Along with the data integrity has to be the priority from the day one, and having strong data governance and tracking the lineage is also critical. So we touched upon those points, and then as we move forward to the future, is basically going to be like AI driven, as we're seeing so much advances in agentic AI on the workflow orchestration part, where there were a lot of steps which were manually performed. Like now we can make use of agents at different points of time for KYC checks, for enterprise data lookups, to move the steps forward to different milestones, and even perform like merge steps and lesser human intervention. Definitely we will need a human in the loop to review and approve certain steps. We need that. Um, so so there is no bias, and we are not kind of drifting away. That's definitely required. But yeah, the future, I think we will have a lot more automation with AI. And yeah, I think that is pretty much it from the presentation. Any questions before we move on to the upcoming sessions? So on-prem, I see one question here which talks about like how does the authentication works between on-prem and AWS. So firstly, we can set up like a layer, or how we are doing the communication between on-prem and AWS. It's going to be through AWS Direct Connect, which gives us which gives us uh, the security, the secure direct connect layer. And on top of it, we are going to have additional levels of encryption uh, and security features, like like every request is over HTTPS, and if it's a REST based request, and then it'll be also uh, using the token, like SAML or SSO token based authentication, which can be applied on top of like every request header. So that's for having authentication and authorization. MSK. So I see the second question. Why do you use MSK? Any other? So MSK is more like self-managed, and to get to the initial pilot phase, I having a self-managed MSK-based cluster with the right level of authorization and authentication really helped. Um, we were able to integrate using SASL-based authentication on MSK, and Spring Cloud provides direct hooks to Kafka-based clusters, like where we can annotate and have topics configured. So it was easier to move to that. With Confluent, there is a licensed version, and then infrastructure needs to be self-managed. Like we need to. So for on-prem based Kafka, yes, there are solutions, teams which are going with Confluence based Kafka cluster. So that has also proven to be useful. But that's like a common solution across different teams are being using that. So yeah, that's for on-prem versus MSK. Yes, we are definitely considering vector DB and other DB products also for NLP models to for document summarization and processing. That's more going through the governance phase. Um, Geographic distribution of the employees. Yes, that's a good question. This is something with I mean, to be honest, the solution that I have worked or I've experienced this, it's more US based. So the users are mostly, the financial users are mostly in the New York or the tri-state area. That's where we have not come across this issue in terms of geographic distribution of, yes, but there are teams in the non-prod environment, we've observed this quite a bit, where there are developers based out of UK or Asia, where if they're trying to hit the same platform, and the servers are in the New York area, there is a lag. So yeah, in terms of different, if there's a high priority mission critical application, then we will have to have separate regions also defined for that. So that has to be one option. Um, I think I've gone through all the questions here. Thank you everyone for your time, and thank you.